Good morning, friends. Myself, Dr. Satish Rikame. I am going to present the concept biodiesel from jatropha seeds. This is the topic related to diploma in chemical engineering, and this is very crucial topic that we need to focus on. The biodiesel from jatropha seeds means bringing agriculture and energy together. Now, what is biodiesel? It is a fuel from a source of oils and fats, an alternative green fuel. Fatty acid methyl esters can be used directly as a diesel or blend with the diesel. The famous Rudolf Diesel designed diesel engine in 1894 to run on peanut oil. The use of vegetable oils for engine fuels may seem insignificant today, but such oils may become in the course of time as important as petroleum and the coal tar products of the present time. An extract from Diesel's speech in 1912. That means this was well given before the time that these vegetable oils or the animals oils will be the next generation fuel for the coming decades or for the coming generation. It was predicted by the famous scientist Rudolf Diesel in 1894. Now the feedstock for the biodiesel: rapeseed from Germany, then sunflower oil, soybean oil, palm oil, linseed, olive oils, cottonseed oils, beef tallow, lard, used frying oil, jatropha, gong pea, and used oil. These are the different feedstocks that can be used for the feedstock for the biodiesel. Now, what is biodiesel? Fatty acid alkyl. Esters prepared from any oil or fats from the animal or vegetable source. Fatty acid methyl ester is a well-known molecule for vegetable oil industry and the intermediate for fatty alcohols and oleochemicals. Mainly the biodiesel is prepared by using two processes: transesterification and esterification. And finally the FAME product, FAME means fatty acid methyl ester, is the product known as biodiesel, with the side products like glycerol and all other cake formation will be there. Why biodiesel? Because sustainability, pollution threat, reduction of greenhouse gas emission, regional or rural development, social structure and agriculture, security and supply. These are the needs. These are the basic things that we need to harvest alternative fuel, that means the biodiesel. Importance of biodiesel: it is very environment friendly, clean burning, renewable fuel, no engine modification, increasing engine life, biodegradable and non-toxic, easy to handle and store. Comprehensive emission analysis for the biodiesel. If we have a 20% biodiesel in diesel, that means the blending ratio, it is also well known, B2, B20 and B100. If B20, that means 20% biodiesel is there in diesel, then NOx production is 0, PM 10.1%, hydrocarbon 21%, carbon monoxide 11%, sulfates 20%, and fuel economy for B20 is 1 to 2%. And if 100% biodiesel is there, then the NOx production is 10%, PM minus 47%, hydrocarbon 66%, then carbon monoxide 47%, and sulfates 100%. That means it caused the acid rain likewise. Biodiesel, why the lower emission is there? Because biodiesel has the high C10 number, inbuilt oxygen content, burns fully, has no sulfur, no aromatics, and complete CO2 cycle is achievable. This is the biodiesel CO2 cycle. No fossil CO2 released, no global warming. That means whatever the CO2 generate, it is renewable CO2. It again captured by the oil crops, from oil crops for the biodiesel production, from biodiesel which is used in cars and trucks, and again CO2 get released, but it is a renewable source. In this way CO2 cycle is completed. What is the challenges for the biodiesel? First thing is that very simple chemistry. Handling multi-feedstock is the real challenge. Very low FFA, free fatty acid, only trans-esterification is needed. If the high FFA is there, then esterification followed by the trans-esterification is needed. Greater than 99% yields to achieve a good quality FEM without distillation. Recovery of good quality glycerol with economic feasibility. Then wastewater recycling is possible. Good pre-treatment is there. Now let us see the Indian scenario for the biodiesel. Presently importing about 8.8 million tons of edible oil, near about 50% of consumption. Clean oils are not available for biodiesel production in the country. Non-edible oils and acid oils not more than 5 lakh tons. To wait till jatropha karanja plantation comes to reality, oil production only after 2 to 3 years. This is the jatropha plants with seeds. See the picture. The seeds are there, plant with cultivated with the seeds. Now the components responsible for the low quality biodiesel: gums, free fatty acids, waxes, unsaponifiable and pigments. Then pre-treatments before the trans-esterification to handle gums and FFA. Physical refining the first step, degumming and bleaching followed by removal of FFA by deacidification. High temperature distillation is needed. Then chemical refining for the removal of FFA using alkali neutralization. Heavy loss of neutral oil along with the soap, 2.5 times the FFA. And then the esterification, which converts FFA to methyl esters, increases the yield of biodiesel, most appropriate option. Now the newer approaches: flexible process for handling variable quality feedstocks with high FFA and unsaponifiables. Then efficient conversions using traditional catalysts like NaOH, KOH, H2SO4, catalyst-free esterification and trans-esterification, application of heterogeneous catalysts for both esterification and trans-esterification. Then biotechnological approaches using lipases, again microbial production of oil and fatty acid methyl esters, and value addition to the byproducts. Now the advantages of heterogeneous catalysis: substantial reduction of waste by product generation, saving on catalyst cost, recycling is possible considerably, greater increase in reactor throughput, smaller heat exchange areas, reduced cost. Then greater ease of automation and continuous processing, sustainable reduction in operating cost, reduction in chemical use, that means catalyst reagents used to neutralize catalyst, and reduction in effluents. This is the biodiesel process. Non-edible oil with FFA plus alcohol and acid catalyst is required for the esterification. Out of that, alcohol is separated. The product from the esterification goes to the neutralization, and with the alcohol and base catalyst. After that, the trans-esterification is proceed, followed by separation into biodiesel and glycerol. Glycerol is almost 50% glycerol is there, which contain alcohol, water, biodiesel, catalyst, soap, salt, and minor constituents. Potential derivatives of glycerol: structured lipids, oxidation product, glyceryl esters, then prodrugs, and triacetylene, glycerol carbonate type of byproducts. Major applications of oilseed cakes present in status: edible oilseed cakes, source of protein in case of clean cakes like groundnut, soybean, etc. Animal feed formulations, non-edible oilseed cakes, manure, to explore for variety of applications. The different cakes are formed. That cakes are useful for the microbial culture. It is one of the best carbon source. From that particular cake we can recover the ethanol. There are so many applications of the cake, and that cake can be utilized for different applications. Huge quantities of jatropha karanja cakes. If these plantations succeed, every tons of biodiesel result in about 2 tons of oilseed cake. Oilseed cake, it is a real asset for the nation as they are biodegradable. Then potential feedstock to make biodiesel industry more attractive, again to develop variety of products from these cakes. Thank you. The source is mentioned for the current slides. I hope this small presentation is beneficial for you. Thank you.